So what we're going to do here is just get a start to some of our evolution notes. So you've learned a little bit about evolution in the past, other years. Also, we've talked a fair amount so far about evolution and what we've done, about reading the works of Darwin and Wallace, our notes, or the video we watched about them. So you already have a pretty good idea about this. So we'll just get a little further. So when we look at this, just to get us thinking about evolution, these are fennec foxes. They live in North Africa. And so obviously they're pretty cute little creatures there. And they have some distinguishing characteristics. And really, whenever you look at a species in nature, you can always sort of ask yourself the question, well, what is that trait? Why is it there? Because for pretty much every trait, it's been selected for through natural selection over the years. So if you see some distinguishing feature on an organism, there has to be a reason for it, usually. So obviously one of the most distinguishing features on the foxes are their ears. What are your thoughts? Why? What would be the value of having those sorts of ears? Jeremy?
So they can hear predators coming.
Okay, so hearing. Okay, large ears maybe help hearing. There might be predators. What? Any other? Because could you imagine a downside in terms of predators?
They're so visible.
Yeah, could it make them more visible? Maybe. Any other theories, ideas about Arda?
Could they use them to communicate with each other?
Okay, could they be communicating with each other in some way? Using their ears?
Because ears are back.
Yeah. Other ideas?
Like a sign to other animals to watch out.
Okay, like a warning to other animals? Okay. Any other ideas? Anything related to their ecosystem? They live in North Africa. Pretty dry, arid conditions, lots of desert. Dylan?
Camouflage.
Okay, camouflage.
What?
Camouflage. Is that what you're going to say, Arpan? Same thing?
Yeah, the ground.
Already got a different idea?
They use their ears as fans.
As fans? Okay. Well, I'll tell some of you we know what the value of them and how they are helpful to survival, but we won't talk about it just yet. Keep you wondering. So let's just get started on our evidence for evolution. So first, let's define it. We know evolution. What do we say as a sort of definition?
Changing a species over time.
Change, yes, and we're going to almost use that, but we're going to make a slight variation. We're going to be more specific, because a change in a species over time is really a change in their DNA over time. So as species evolve, their DNA changes. It's a change in their genes, because their genes determine their characteristics. And there's one really important thing to always sort of remember, because this sometimes confuses people. Here's some different species. Can this individual organism adapt over time and become this one?
Yes.
This individual, this one specific
Yes.
individual.
No. Oh no, because
No.
he's got the It's-
So individuals
Oh,
don't evolve. They don't adapt over time. Then what does? What are we talking about?
A whole species.
A species, a group of organisms, a population, we might say. Population, the frequency of different characteristics over time can change, which leads to evolution. But individuals do not adapt and evolve. An individual is born with certain genes and characteristics and dies with those exact same genes. They don't change during its lifetime.
Is there species that those change over their life?
Not over a single life. It has to be many generations in order for changes to take place. So evolution is a theory in science, and we've talked about in our last unit what that means. It means it's well substantiated. It's been shown in many experiments support evolution by natural selection. It's been repeatedly tested and confirmed. It's sort of the main principle that underlies basically all of biology. This picture just shows some intermediate steps in the evolution of whales. Whales actually evolved from land mammals, okay? Sort of wolf-like creatures that went through a series of transitions, eventually becoming more and more adapted to life in the water until we
Wait.
eventually ended up with whales.
Wait, so those things,
Those are
The top?
intermediates. Yep.
at the top, those things are land creatures?
Yeah, these are, and then these populations spent time in and around the water. Eventually, some of them became better and better adapted to life in the water, and that's what eventually led to
How
that.
did they know that?
We can find fossils of these intermediaries in the same, different.
So what is that animal at the
environments.
top called?
I don't know what it's called, what the name of it is. Talia?
So like over time, could we like be able to breathe underwater?
So the key thing is that the variation needs to be present, right, in order for natural selection to act upon it. Like, could a hamster evolve to have wings? No, because there's no variation that leads to anything related to wings. It has to be a natural variation within the population in order for natural selection to work on it. So it was, Art, did you have a question?
I was just gonna ask if they're just get it.
No, they're not this guy.
No.
So,
it's
Darwin and Wallace
The whale.
did not originate the concept of evolution. They proposed how it happens, but people have been thinking about species changing over time for thousands of years. As far back as ancient Greece. In ancient Greece, there were philosophers that proposed the idea that species could change over time, and one species could change into another. Obviously, it's something we know is correct today, but they were thinking about that all the way back in ancient Greece, 2,000 years ago, 3,000 years ago. In China, Taoism suggested that species are not fixed in time and unchanging, that they could change. In ancient Rome, philosophers described that the earth changes based on natural laws, not just based on supernatural, divine principles. And so people believed in some of these things over time, but didn't have the mechanisms or how it happened. In the Middle Ages, as Christianity became the dominant religion in the Western world, most Christians believe that the species we have, they believe in what we would call special creation. That the species we see today all around the earth were created specifically by God, placed on the earth, and they are unchanging. They had never in the past been different. They will never in the future be different. They are what they are, and they always remain that way. However, at the same time, in Islam, philosophers were talking about and mentioning in their writings evolutionary ideas about species and changes over a period of time. As we continue to move on in time, in terms of Western culture and the Renaissance and Enlightenment, again, most people still believed in a unchanging Earth. And that the Earth has always been the way it is. Species are always been the way they are. People try to trace back the age of the Earth by a very literal interpretation of the Bible. They would go back and try and count the generations of people that were mentioned in the Bible to see how long has the Earth been around. And the number they eventually arrived at was around 6,000 years old. And most people believe that's how old the Earth was, which is not that old. But there are some scientists. There's one French naturalist, Buffon, in the 18th century. And he proposed some things that take us pretty close to what some of the more advanced ideas of the 19th century were about evolution. That modern forms of organisms evolved from previous forms. That some lions and tigers and cats, they had a common ancestor at some point in the past. People started to believe that maybe the Earth is not 6,000 years old. Maybe it's actually much older than that. And then the 19th century arrives, and then thinking really starts to change. It starts in geology. Geologists Hutton and Lyell, who we just read some of his writings, started to propose the idea that the Earth is not just 6,000 years old, that it is much, much older, millions of years billions of years old. And they started to examine fossils of things that are extinct. And so we start to learn that maybe the species that were once on the earth are no longer here, and that they weren't always unchanging. Another scientist called Lamarck came up and proposed some ways he believed that species adapt to their environment. Again, getting closer to Darwin. His ideas were not correct. He believed in this concept that as species use a certain body structure more, it becomes more developed and more pronounced. And that changes within a species' lifetime could be inherited in the next generation. Lamarck believed that giraffes increase the length of their neck by stretching it, and then that stretch being passed on to the next generation until eventually it led to all giraffes having these long necks. So although his ideas about how it happened were not correct, his ideas about what happened were. And then in the end of the 18th century, Thomas Malthus, this gentleman here, actually no, that's Lamarck, wrote an essay about population growth, mainly focusing on humans and nature. And what he said is that there are certain checks on population growth, disease, famine, things like that, that limited the population of people on Earth. Okay? And Darwin had read this work and sort of applied these principles to the natural world as well, leading to think about this overproduction of organisms, and that which ones survive must be based on their specific variations and traits. And that's what led him to start his thinking on natural selection. We'll talk more about Darwin tomorrow.